Okay friends, today in the geomorphology class, we will discuss about this energy flow in geomorphic system and role of uniformitarianism versus catastrophism. What does it mean? In geomorphic system, if you remember our last classes, we are talking something about the geomorphic processes. It may be fluvial process, it may be aeolian process, it may be glacial process or any process is involved and weathering and erosion is involved. So, we need energy flow from one form to another form and we need material. Either material has to be added or is to be removed. In any case, we need energy and material together. And in geomorphic system, to sustain for a long time, this energy and this material has to be balanced. If it is not balanced, what will happen? For example, suppose we have more energy available in the system, but less material. So, there will be dissipation of energy, there will be loss of energy and there will be less work done. Similarly, suppose we have more amount of material available, but less amount of energy available. So, the system will not work, the system will be not long lived, it will be short lived and one system will be segmented into different subsystems. So, that means I want to say to sustain a system in a geomorphic system for a long time, we should have a balance between this energy and material together. And whatever the geomorphic features so far we have discussed. So, some of these geomorphic systems or some of these geomorphic features that were formed uniformitarian process. That means, it is a gradual process. Gradual process, it will take long time to form, it will take long time to come into balance. And some of these systems which are called catastrophic systems. Catastrophic system means within a minute, within an hour, within a day it will happen. For example, suppose we want to create a mountain system which is relict mountain system, for example, it in the Eastern Ghat. Eastern Ghat is a relict mountain system and it is this uniformitarianism approach. If we move, that means it has taken a long time to form. But in terms of our Himalayan system is concerned, Himalayan system it is catastrophic process. That means, a tectonic process within a long geological time involved, a lot of energy, a lot of material is being added to this surface of this earth. So, that is why it is a catastrophic system. So, in today's class we will talk in detail how the energy flow occurs in a geomorphic system and the role of uniformitarianism and catastrophism, how they work together or separately to modify a geomorphic system and to modify these topographic processes. So, what does it mean? So far we are talking about the system and system. What is a system in geomorphology is concerned? System, it is a collection of objects and those objects has to be related to one another with some process. For example, we have fluvial system. Fluvial system means there is river involved, within river there is erosional topography, erosional landforms they are involved, there are depositional topography and depositional features are involved. So, erosional landforms and depositional landforms, the fluvial process, the river, the streams, the floods, they are related to each other. So, this is a complete system, it is called fluvial system. Similarly, take another example about the glacial system. It is the glacier is the medium, the glacial topography either it is depositional or it is maybe erosional. All those they place side by side. At the upper reaches, the erosional topography will be dominant, the erosional topographic features will be dominant and at the lower reaches where the glacier melts down, the depositional features and depositional topography will be dominant. So, it is complete system, it is complete a glacial system. So, that means system means it is a collection of objects placed side by side and they are related to each other. So, now the question arises, if this is so, the system can be divided into two parts. One is called the closed system. Closed system, that means material and energy they are restricted. That means material cannot be transformed or transferred to a boundary beyond that is called closed system. Similarly, energy cannot be transferred from this system beyond that boundary, that is called closed system. Generally in geomorphology, closed systems are very rarely found. Even if their closed systems are there, they are not long lived. So, that means with time, if closed systems are there, with time, with subsequent geomorphic modification, these will not sustain. So, they will be divided into small and small and small systems, finally that will not sustain and will vanish from the earth crust. So, that is why I want to say, though closed system has been defined, they are very rare. Simplest geomorphic processes, they are the closed system and it is very rare. Now, open system means both energy can be transferred, but material can be transferred. For example, we have a fluvial system. From fluvial system, we have rivers, they are deposing to their water to the sea, they are transporting their sediment from the upper reaches, from the surroundings, and some of these sediments they are deposited in the floodplain, some of the sediments they are deposited within the river bed, some of the sediments they are going into the sea. So, finally, we are having a open system, that means from the upper reaches to the open sea, the system is any changes in the sea, any fluctuation in the water level in the sea, it will affect the fluvial system, it will affect the sediment production, it will affect the sediment transportation, it will affect the sediment deposition. That means one system, if it is changing its position, one system if it is changing its property, it is affecting to the another system. So, these are called the open systems, and many of the geomorphic systems and the geomorphological domain is concerned, many or rather most of the systems they are open system, and closed systems they are very rarely present here. Now, here these examples are given, the systems. If you see here, these are the desert systems, this side they are the desert system. Desert system means desert geomorphology is concerned. Here we can expect the dunes, the different types of dune, the volcans, the star dunes, the longitudinal, the transverse, similarly ripples, and this erosional topography, the yardungs, the gyra, whatever may be these. So, this is completely a geomorphic system which is isolated. Similarly, this side it is fluvial systems, this side we have marine systems. So, these are the systems, they are independent in their domains. Closed system, a landscape with wetland, estuarine, lakes, they are the closed systems. So, now we are talking about material and energy management within the system. So, you see material is being added by tectonism or volcanism and very small amount by meteorite fall. Tectonism we know, Himalayan system, it is formed by tectonism, tectonic process, Eastern Ghat, Western Ghat, all mountain systems in the world, not many, all mountain systems in the world, they are formed by tectonic process in geological time. So, the main work or the main theme of tectonism is it adds material on the earth surface, it takes from below, it adds on the earth surface and creating a topography. So, that means it is a geomorphic, it is creating a separate geomorphic system within the surrounding. Similarly, meteoritic fall, though it adds material in this geomorphic system, but its contribution is very small. Some meteoritic fall are there, varies from very size or varies weight from kilos and some grams or so. So, it is emitters, that means though it is meteoritic fall, though it is adding mass to the system, but as compared to the large mass of the geomorphology is concerned, it is very negligible. Then comes to energy. What should be the source of energy to sustain a geomorphic system? Mostly the energy involved in a geomorphic system, it is the gravitational energy. So, gravitational energy means its source is sun, the moon, is not it? In the solar system, it is the gravitational energy. Then the inertial force associated with the mass of the motion. Then some internal energy means it is the heat dissipation, it is the movement of this mantle. So, this is also providing energy to the system. So, that means mass and energy both are related both are available within the earth. Very less amount of energy is, or very less amount of material is being added from the extraterrestrial systems. If you see and you compare the energy systems available from different source, you can see the solar radiation. If you see, note down here, the solar radiation provides the energy for a geomorphic change at rate 3300 times faster than any other energy source. So, to sustain a geomorphic system for a long time, solar energy is very much required. Then subaqueous, subaerial, subsea processes erode the rocks from one place to another. So, erode the debris deposited somewhere else, this also needs some energy. That energy is, that means solar energy is divided into different forms, and all other forms of energy they also provide to the geomorphic system to move the material from one place to another. So, this is the management of energy and matter within a geomorphic system. As we have discussed earlier also, in a geomorphic system the matter and the energy must be balanced. If it is not balanced, that means a geomorphic system will not sustain forever. It is very short lived. For example, if you see here, notice here, this is a longitudinal profile of river. It is in steady state. It is at equilibrium. That means to sustain this river to flow, it has to be this river bed geometry should be like this. But if you see here, suppose there is faulting in between. So, that means it is creating, it is adding material here, and nature has a property that it will not keep this surface uneven. Always 24/7 the natural processes, natural agents, they are acting 24/7 to make the surface plane. So, that is why if you see here, gradually there will be erosion. So, due to erosion, this side erodes and the material produced here, that will be deposited here. So, with time this part, this mass is totally eroded out, and this eroded material is being deposited here, and finally this is the longitudinal river profile occurs. So, that means earlier it was started and it ended with like this. So, in between there will be imbalance, and that is called temporary imbalance in a geomorphic system. So, temporary imbalance means it is not long term, it is a very short term as compared to geological time is concerned. Short term means in a geological time is concerned, it may be thousands of years, it may be millions of years depending upon the terrain as is discussed earlier. If this happens in a fluvial system which is very alluvial system, unconsolidated material, this unevenness will not sustain for long time, even if hundreds of years or thousands of years the system will penetrate it. But if same happens in a hard rock terrain like the peninsular system, the system will continue for millions of years. This unevenness of the geomorphic system will remain there for millions of years or for lakhs of years. So, that is why these things, these are temporarily available or temporarily sustaining, but in long term geomorphical system is concerned, this has no place. So, it means nature always wants by its natural agents to make its surface plane. If you see here, climate change, it also plays a major role in modifying the geomorphic system. For example, suppose we are talking about the geological time when the arid climate was concerned or arid climate was dominant, or we are talking something in geological time when the humid climates were dominant. We know in humid climate more rainfall, more sediment production, more weathering and erosion, is not it. So, that means material will be more, energy will be more, and that will be transported from one system to another system. So, within a system from one end to another end. So, if it is arid system, it is a cold desert, cold area, there will be no raining, material will be produced by physical weathering, but will remain there, no transportation because energy is not available. So, that means climate change also affect the geomorphic system to certain extent, and its role is very prominent. There are many climatic change records have been noticed and they are preserved in the rock body. It has been noticed during this humid climate conditions, the penetration system of the earth is uniform. However, during this arid system, either it is cold arid or it is hot arid, some of these geomorphic processes, they are restricted in some geographical environment. So, this energy and material distribution on the earth crust is not uniform. In their cluster form, the energy is dissipated, the energy is used, and in cluster form the material is transported. But if it is humid climate, if it is warm and humid climate, there will be uniform distribution of energy and material throughout the time. So, this climate change, it affect our oxygen cycle, our carbon cycle, nitrogen cycle, sulfur cycles and many more. So, that means by one way or other the geomorphic system is being affected. So, that climate plays major role in modifying the geomorphic system. Now, you see long term and broad scale interactions between landforms and climate. Suppose we are allowing the climate to interact with the landform for a long time. Again, long time means what type of climate with which we are dealing with. If it is arid system or arid hot arid or it is that is cold arid, we are producing sediments, we are producing materials, but the material will remain there, material will not be transported. If it is cold arid, if the glacial system is there, then glacier will transport this material to certain extent, but glacier has its own limit, it cannot transport to nth extent, it has certain own limit, is not it. So, that means I want to say the climate change that affect the system, the geomorphic system, that affect the water budget, that affect the vegetation cover, that affects the human activities, all those things they affect our geomorphic system. For example, if you see this figure in arid climate, these are the indicators, the mud cracks, this aridity. We have rock record within which mud cracks are very well preserved. That means, here the geomorphic system is affected. Here if you see, we have Sundarban delta, there are many delta have been submerged. If you see here this map in island in 1969, island position in 2001. That means, substantial changes in area. Why? This is due to the climate change. So, the climatic change affect our marine system, this affect our continental system, similarly they affect our glacial system also. If you see here mid oceanic Atlantic ice, here Antarctica today in the sea ice. So, if you see this ice percentage from here to here, there will be drastic change, this is due to climate change. And due to climatic change, if we are restricting our geomorphic environment, we are squeezing our geomorphic environment to certain domains. So, that means within one domain we are creating small subdomains. Earlier if you see, this was the position where this glacial system was dominant. Now, the glacial system is dominant here, but what about the rest of this area? This is by the marine system. So, that means with time, with change in climate, with change in topography, with change in tectonism, one system dominant over other, one system takes away regions from other. So, where nowadays a arid climate is continuing, in geological past you can say there was cold climate was continuing there. So, that is why these things are, these evidences are preserved within the rock record. So, that is why I repeatedly say, if you are able to unravel, decode these geomorphic systems from this rock record, you can unravel the geomorphological history of that region. Now, whatever the energy, whatever this material it is used, energy from one form to another, material from one place to another, does this energy work repeatedly into 24/7 or the rate of energy flow is same throughout the geological time? If you see here, there are two schools of thoughts. One is theory of uniformitarianism, another is catastrophism. What is uniformitarianism? The school says the whatever the geomorphic topography we have nowadays, either it is erosional topography or it is depositional topography. These topographies they form gradually. Gradually it takes long time to form. This is the uniformity regime approach. This theory of uniformity regime it was proposed by James Hutton. So, James Hutton he noticed first he observed that the rock is broken down into small particles. Then he watched these rock particles were carried downstream. He saw the rock particles are deposited and that they form new layers of sediment. He predicted these deposited sediment will form new rock in future. Then Hutton thought that in time new rock would be raised, creating new landforms, that the cycle will continue. So, that means it was the theory of uniformity regime or uniformity regime approach that all those landforms they were formed gradually with taking long time. But catastrophism it is another school of thought. It says that no, this uniformity approach is wrong. Many of these landforms or the landforms they occur overnight. Within a small time you will find huge landforms. So, earth has been affected by sudden, short lived violent events that are sometimes worldwide in scope. So, this catastrophe can be a function without the assumption of long time. So, that means catastrophic events they are short lived event. Suppose there is an earthquake, there will be a fracture, there will be huge mountain building systems, huge mountain will build up within a minute, within an hour. So, that means catastrophism versus uniformity if we say, catastrophism says it is the landforms occur suddenly, but uniformity regime says the landforms occurs gradually with time. Uniformity regime lost the debate until the Charles Lilly proved Hutton to be right. This Charles Lilly he was the key partner of the geomorphology. He supported the James Hutton's theory and argued yes, Charles Hutton was right that many of these landforms they occur gradually. That does not mean there was no catastrophic event. There is catastrophic event. Suppose earthquakes, volcanism, landslides, they are catastrophic events, they occur, but many of these landforms, they were formed gradually, that is by this uniformity approach. So, that means if we take long time span in a geological time scale, suppose you take for example thousands of years or millions of years in a time span, within that time span the graph will move smoothly. Within that smoothness there will be some zigzag that will affect this uniformity approach to catastrophic approach. So, those are the catastrophic events which are responsible for the modifying the system. So, here some examples of catastrophic event, it is photographs from Nepal earthquake. After Nepal earthquake these are the systems of roads, this is the position of the road. You can see there is a depression, there is a landform, small landform form. Similarly, we have volcanoes, it is catastrophic event. Boloid impact, it is a catastrophic event. Tsunami, it is a catastrophic event. All those events they transport material from one place to another. They release huge amount of energy. So, both energy is present and material is present. So, that is why they create new landform within a small time. Similarly, if you see this geological time scale from 0 to 600 million years, so you will say here there are the catastrophic event, PT boundary, KT boundary, NQ boundary, Precambrian Cambrian boundary, these are occupied or these are characterized by catastrophic event. So, that means there are smoothness in a curve, within that smoothness there are catastrophic event, they are short lived and finally they release huge amount of energy, huge amount of material and forms landforms within that. So, within a gradualism approach we have catastrophic approach too. So, that means we can say both catastrophism and uniformity regime, they both are responsible for modifying and formation of the landform on the earth crust. So, now if you see, if you compare these three, one is catastrophism, another is uniformitism, and in between it is called gradualism. That means, where catastrophic, we have some catastrophic events, volcanoes, floods, earthquakes, landslides. Once they form, the geomorphic system takes long time to respond. One event is there, but to respond the geomorphic system to that event, it takes long time. So, this is called gradualism. So, gradualism means it is the junction or it is the transition between this catastrophism and uniformitism. So, mostly it is the time taken for this the compensation, or it is time taken for the response of the geomorphic system to that catastrophic event. So, this is all about. So, if we can conclude this class here, we have three approaches. One is called catastrophic approach, another is called uniformity regime approach, and in between we have gradualism approach. So, catastrophism, it is the sudden events that create the landforms. Uniformity regime, it is the slow processes that create the landforms, but this gradualism approach is in between, which is a transition between the two, which set the response time. That means, to catastrophic system, geomorphic system respond to come to a uniformity regime approach. In between this time span, it is called the gradualism approach. So, whatever the event is there, whatever the geomorphic system responds within that time, that is called gradualism approach. So, it is the conclusion, and we will meet in the next class. Thank you.